Hi, Michael McGurk here from DT2283 Software Engineering 3. Just to talk through my first deliverable for the assignment. So basically what I'm going to be talking through is the use case diagram, the class diagram, and the sequence diagram for my project, which is based on a student services system. So a student can log in, and they can enroll in the course, and they can view the current modules they're sitting on that course. So the three main use cases here in the system are login, enroll in course, and view current modules. So login is pretty straightforward. Enroll in course is basically when a student can, if they're not currently enrolled in a course, if they're a new student, they can pick their course and enroll in it. And then the view current modules just basically shows them a timetable based on that course they're enrolled in. So turning to the class diagram here, I've followed the command factory pattern, or the command pattern. So basically what happens here is, depending on the request by the user, whether it's a login or get timetable or an enroll, it'll call either of these classes. So the command factory, based on what the user requests, will instantiate a class based on that request. So we have the login student command, the enroll student command, and the get timetable command. So for instance, if the student goes to log in, it creates a login student command class, which then instantiates a student service class and then a student DAO class. So the student DAO class is the one which creates an object based on the information it takes from the database. So when a student goes to log in, if all their details are correct, it'll pull the information from the database and create a student object, and then that's what's then returned to the front controller for it to be parsed in for the data that the user is presented with in the UI. Multiplicity wise here, a student can only be part of one course at one time. So they can either be part of no course, not enrolled yet, or part of one course. The course class then holds a list of student objects, so there's a limited number of places in the course, and in the course object holds the amount of students that are in the course. Similar with modules then, basically a course holds a list of modules, and a module can be not part of a course, or it can only be part of one course at one time. So that's really the multiplicity covered there. The rest of the relationships and associations here are dependencies, so realized relationships. So these are kind of classes that are objects that are created on the fly by objects as they go. So within the execute command, a student service object is created, and within the login method here, a student DAO object is created, and then within find student by ID, a student object is created from the data that's pulled from the database. Coming to the sequence diagrams here, they basically just follow the pattern there. So they all follow the command pattern and follow pretty much the same kind of structure. So the do post method takes in a message from the HTTP request basically. The process request method checks for an instance of the singleton command factory class. If there isn't one there, it creates it. If there is, it returns it. The create command then creates the appropriate command class. Execute is called in the command class by the front controller. And then it goes through so for in this example, it goes through the student service, creates a student service object, which then calls a student DAO object, and the student DAO object then creates the student object that is then returned to the front controller class. That's pretty much it. Just looking here at the other sequence diagrams, they follow pretty much the same pattern. So it's the command factory pattern and how the data is accessed and then returned to the front controller, and similar with the add student.